basically, in the certificate you have a validity period. So basically the CA can guarantee that this certificate is valid for this domain for a certain period. So afterwards, the CA cannot guarantee that the certificate is valid. So basically, you can't validate the identity of the other party. Okay, so basically, if your certificate has expired, then they will give you a warning whether you still have to proceed on connecting to the entity. Okay, so in this case, Alice chose to connect. So what are the potential security risks by doing so? What could happen after the certificate has expired? In the first place, why would entity want a CA to issue them a certificate? So there's an identity in the certificate. So with the certificate, you can say that I'm this entity, right? So if after this period I don't need a certificate, I don't need to renew a certificate, right? So the certificate that's being used is still the one. So what does that mean? If I'm not using a domain anymore, do I still need a certificate? Alright, so after selling the domain to someone else, I don't need the certificate for my domain anymore, right? Then if someone uses that domain that I sold, right, and creates a malicious website, right, and you trust the website based on the expired certificate, what will happen? Remember that your certificate is still using the same public key as when you're still valid, right? So with the public key that's on the certificate, what can the previous owner do? What does the previous owner have? Yeah, so the previous owner will have a private key, right, because he owns the certificate. So with that, even if someone else owns the domain, you're connecting to the domain, but then someone else, a third party, can still intercept your communication and decrypt whatever messages that you send, right? So that's one risk. Another risk is quite common. Okay, so like let's say I work for this company, so this company owns a website and I'm the web admin, okay? I manage the certificates, the encryption and stuff, right? But I have an issue with the company, I left the company, but I still have the information that for my time in the company, right? So the private key, all the private keys that they use, right? So after I left the company, if they're still using the same keys, I can still steal some information, right? Yeah, so there's some risk. Okay, so basically, because in the signature, right, you can verify that the certificate is authentic, is correct one, but it's just not valid anymore. Okay, so this is supposed to be D3. So we need D3. Okay, so basically, if there's a different owner, the previous owner will still have a valid certificate and can use that against you. Or if there's basically a ex-employee there's a dispute, so basically disgruntled employee, they can still use it against you. Okay, and it's called insider attack. Then there's another scenario, but it's like very contextual. So if the certificate is like quite old, like 10 years ago, you are still using SHA-1. So you know that SHA-1 you can find a collision quite easily. So you can forge a certificate, right? That's one thing. But that is if the parameters are given. So it's based on the parameters of the question. Okay. And this is not the answer. Okay. Question 2, basically you have a monitor, so F for in the middle. So when okay, so in this question, the context basically the school wants to monitor all of the connection going in and out of the school network. Okay, so basically since you know that HTTPS, the data is encrypted, so anyone in between are not able to read the data, right? Even if you are the man in the middle. So basically, even if the connection goes through you, you are still unable to view it because it's basically it's secured using HTTPS, right? So in this case, I think the question mentioned it, but basically it's saying that M will drop all connections with HTTPS because they are unable to view you. Okay, because the school wants to be paranoid, something. Okay. Yeah, so when Alice visits this website, HTTPS, right, the monitor M will drop the connection, right? So it's basically explain why dropping a HTTPS is not desired. And basically this is all HTTPS connections, right? So why is this not desired?
It will not be secure if you drop it.
Not secure is one thing, but
No end-to-end encryption, is it?
that's one thing. But the main thing here is how many when you visit normal websites like Google, Facebook, YouTube, Instagram, right? Are all these connection encrypted? No. HTTPS means there's a valid certificate between you and the entity, right? So you encrypt using a public key, only the entity can decrypt using a private key. So that's your encryption. So dropping of HTTPS will result in basically dropping all connections that's encrypted, which is probably a majority of connections, right? You are able to visit YouTube, Google, or any website that uses a certificate, which is like probably most of them. So usability is affected. You can only visit unsecured websites. Then that will lead to like more concerns, right? Okay, so then at least protested. So now the school allows students to visit web page with HTTPS, but mention that the monitor is able to decrypt and expect the communication. Okay, so basically you have two methods to do that. First thing is you restart program and the monitor will basically use the key that you establish with session key established with the entity, right? To monitor your connection. So basically now you're using a symmetric key encryption to communicate with the entity. Then now a third party will have the symmetric key, right? So that's one thing. Second solution is a bit complicated. Okay, so now student accept a self-signed certificate, right, signed by an entity with the name school CA and public key. The certificate states that school CA can issue certificate and it's a CA. So the school and the monitor knows the private key of the public key. So whenever someone wants to visit a secure website, the monitor can carry out what you call proxy re-encryption to decrypt the communication and re-encrypt the encrypt. So this is the main part of today's tutorial. Okay, so to give you step by step. So when Bob wants to visit, Alice wants to visit Bob and monitor and in the middle, Alice will carry out your TLS handshake with Bob. Okay, so basically in this case, your M is in the middle between Alice and Bob, right? So when Alice attempts to set up a certificate connection with Bob, Alice is actually setting up a connection with M, right? So in this case, when M generates a certificate, what certificate is he generating? We know that M is a CA, right? So when M generates a certificate for himself, what is the entity here? Remember in the last tutorial, mentioned that who needs a self-signed certificate? What kind of CA needs a self-signed certificate?
Root CA.
Yeah, so basically, in this case, the school CA is acting as a root CA, right? So basically, there's no one to issue certificate for them because they are not entirely legit. So they are issuing certificate for themselves and they're acting as a CA, root CA. So now in this case, what's the content of the certificate? The public key, what's the public key of the certificate? You should know this because given. No. The public key here is your KE, which is given here, right? What's the entity? Who is Alice connecting to? This question.
Happy to.
Yeah. So basically the certificate that Alice needs is for the website, right? So in this case, if M wants to add as a man in the middle, he has to generate a certificate for that website. Right? But basically the certificate for Bob is not generated by the CA but by this CA in the middle, so man in the middle. Right? So basically the name here will be happy to because that's what M wants Alice to think that the certificate is called. Okay. Then the public key is the KE which is given. Okay, then other than the validity period, there's a signature which is done using the public key of the CA. Make sense? This part is the same for all certificates. Right, so now Alice will accept the certificate generated by M because why will Alice accept the certificate? Okay, so in this case, M right is acting as a root CA, right? So if Alice accepts M as a root CA, Alice will accept certificate, right? Because you trust your root CA, you trust any certificate issued by the root CA, right? Then in this case, the key action will be carried out because M knows the what of the public key. Yeah, so basically private key or public key. So this is your K key, this is your K, but the KD of the key basically. Then it's quite the same. So encryption, you establish a session key which is the pair KATA, subsequent communication M and then within M and Alice will be encrypted using what? You have your KA and the TA, right? So which one is used for encryption?
KA.
Yeah, so you encrypt using KA and authenticate using TA, right? TA is the key for the hash, the hash bank, right? It's because you have key hash. So this is the key for the hash, right? Then Bob earlier M performs the authentication with Bob using M uses a public key to verify someone's authenticity, right? So now basically M is taking over the job of authenticating with the website itself, right? So now you can see M as just a normal user. They want to connect to this website, right? How would M do it? If you're a normal user trying to gain access to connect to a website, how will you verify their authenticity? What's the thing we use to verify authenticity of a website or entity? Yeah, that is a certificate lah, but how do we actually do it? If the CA issues a certificate for a certain website, how do we use the certificate? How do we use what we have to validate the certificate and validate identity? Which part of the certificate is used for validation? Signature, right? So how do you validate the signature?
SHA-256.
But how? Like, I think don't need to know the process, I just need to know what they use.
The public key
Of who?
of
The website.
The website? Trying to recall last tutorial. Because the public key of the website is given in the certificate, right?
Yeah.
If the certificate is compromised, how do you verify it? Right? Or like in other words, like I can modify the public key on the certificate to be the public key that verifies the signature that I made up. Right? If I'm an attacker. So that's not and using the entities public key is not the case. Remember last tutorial?
Is it connected with the birthday attack?
No. It's fine. Remember this part? Signature is computed using a key with a message. Right? Whose key is used to compute the
Public
signature?
key.
Do you remember?
Well, the public key is the signature, then gives you the message, right? Is it?
So in this case, who completed the signature?
The CA.
The CA's private key. So correspondingly, if you want to validate the certificate, what do you use?
The CA's public key.
Yeah, so this is your CA's public key to verify your entity's authenticity. So in this case is Bob, right? So same thing, now we have a configuration with Bob. So using your KB and ATV, so your private key, your symmetric key KB and your key for your hash is ATV, okay? So now whenever Alice sends a message to Bob, right? Alice will encrypt it using what?
KA.
K, yeah. Then as man in the middle, M will intercept the encrypted message and decrypt it using,
KA also.
yeah, so KA cause it's symmetric encryption. Then inspects it and re-encrypts it using
KB.
KB. Okay, then same thing for the MAC. So the same thing goes for the other direction. So Bob will encrypt using KB, send to M decrypt using KB, then encrypt it using KA and send to Alice. Right? So that's the entire thing. But in this case, what they are trying to do is to show you the like how much power the CA actually holds. Right? You are trusting so many CAs by default, but if there's a CA that goes rogue, basically they start issuing certificate, they can act as man in the middle for a lot of stuff, right? So they can basically they can like look at all your data, right? So in this case, you can say that M is a rogue CA, but in this case it's just information privacy. Yeah, so which solution S1 or S2 is preferred? Okay, so S1, you see that S1 here, what you're doing is installing a program on the machine, then the monitor will do the following whenever a browser wants to make a connection. So let the browser complete the handshake, then the browser will send the T to M, then M will use A to inspect the message. Right? So what does that require? Okay, so each browser has their own protocol for completing DRS handshake, right? So if you want them to include sending you the key in their handshake process, you will need to modify their browser. So for every single browser, you will modify them, right? So it's not really feasible. Okay. So that's pretty much it. But yeah. This is the problem. You change the browser. Okay. This will be given to you, so but for the endpoint is still question 2. So like your key exchange, if someone is in the middle of the key exchange, someone can authenticate in both directions with you and their entity and act as the man in the middle. So anything that you send afterwards, right, will be the confidentiality is breached. So everyone we can can see whatever you said. Right? If you look at your actual notes, there are some key exchange like Diffie-Hellman and key exchange. So you can imagine you can think of how would the attacker compromise the key exchange method. So like how would they do this kind of man-in-the-middle attack during the key exchange, right? If you are interested, you can take the next security module to learn that. But yeah. So in this case, if this is a normal man-in-the-middle attack, the M or Mallory will be impersonating as bomb towards Alice and impersonating as Alice towards bomb. So that's what